Hello guys, this is Edward from STEM. Today we are going to be looking into GCSE Paper 2 Physics revision exercise. We are going to look at series of questions that are found in Physics Paper 2. But before we continue, if you haven't done so, kindly subscribe to my channel, like the video, share, and drop a comment if you have any question. And don't forget to turn on your notification bell so you get to be notified whenever a new video like this is dropped. So let's take a look at this question. It says, figure 2 shows an open door. Explain why it is easier to close the door by pushing at point P rather than pushing at point Q. Yeah, so we have to point on the door, point P and point Q. Why is it going to be easier to push or close the door by pushing at point P rather than pushing at point Q? Now that is the question. This question has to do with moment. First of all, you need to understand the concept of moment. You need to refresh your memory on the concept of moment. And moment basically is the turning effect of a force, applied to a rotational system. So basically, the moment is the force multiplied by the distance. That is your moment. And your force is measured in Newton. Distance is measured in meters, right? So the unit of moment, therefore, is equal to Newton meters, right? Now, so have that at the back of your mind, because I believe you're going to need this knowledge, in answering other questions that will relate to moment. Okay. Now, the whole idea behind this is that the increase in distance between the point where you're applying the force and the hinge will result to a greater moment. Okay, will result to a greater moment. But if the distance between their point and the hinge, for example, as in case of point Q, if the distance is smaller, the moment will be smaller as well. So it will require a much higher force when you apply, for you to close the door on point Q, you need to apply a larger force compared to closing the door at point P. So now the increase in distance between point P and the hinge, the increase in distance between point P and the hinge, therefore will require lesser force. So that is basically the whole idea behind this, answering this question. I hope that makes sense. So let's look at another question. Figure 3 is a diagram of the forces acting on a swing. The swing is not moving. Let's take note of that. The swing is not moving. Now, the seat of the swing AB is 0.8 meter long. So this is 0.80 meter long. A person of weight 450 Newton sits on the seat. So this is where the person is sitting, 450 Newton. Yeah. Okay. Now the person weight acts at a distance of 0.50 meter from A. So this is the distance between where the person is sitting and the point A, and that is 0.50 meter. So then ignore the weight of the seat. The upward forces exerted by the ropes on the seats are F1 and F2. So we have F1 and upward forces, F1 and F2. Okay, now the question is calculate the force F2 by taking moment about A. Now this question still is about moment, okay, but it's a moment that has to do with equilibrium. Now I'll use another example to illustrate what equilibrium is all about before we able to answer this question. Now let's say we have a ruler balanced on a knife edge, and don't forget the definition of a moment. So moment is basically the turning effect of a force applied to a rotational system, as I've explained previously. Yeah, so now let's say we have this metal rule that is balanced on a knife edge. Yeah, and for this to be balanced, it means that the moment acting on this side, there are two moments acting on this system here. We have the clockwise moment that is from this side, clockwise moment, and we have the anti-clockwise moment this side. So now for this ruler to be balanced, it means that the clockwise moment, yeah, is equal to the anti-clockwise moment. Okay, so that is just the base, and that is the basic concept of the equilibrium in moment. So now let's apply that to this question here. Now, but this question has to do with a string, yeah. But like we have highlighted earlier, that it says that the swing is not moving. It means that the system is in equilibrium. Okay, it is equilibrium. Now, so let's see how we're going to answer that question. So now for it to be equilibrium, it means we have a clockwise moment and we have anti-clockwise moment. So first thing we're going to do is to identify the clockwise moment and then identify the anti-clockwise moment. So this is the point A. Okay, this point A basically is a reference point, yeah, and we have a man of weight 450 Newton, okay, that is sitting, and the distance between where he's sitting and point A is 0.5 Newton. So let's take this down to be our clockwise moment. So for our clockwise moment therefore will be equal to 450 Newton multiplied by the distance. The distance is what? 0.5. Yeah, and what would that give us? 450 multiplied by 0.5, that will give us 225. So 0.5 meter, so that will give us 225 Newton meter, and that is our clockwise moment. So let us now, our anti-clockwise moment therefore will be this F2, all right, the F2, the force on this F2 multiplied by the distance. Now what's the distance between the F2 and the point A? That is 0.80. So our anti-clockwise therefore is equal to F2 times 0.8. Yeah, we are looking for F2, so let's equate. Remember that this system is in equilibrium, right? Which means that clockwise moment is equal to anti-clockwise moment, and our clockwise moment is 225 Newton meter. So we have 225 will be equal to, our anti-clockwise moment will be F2 multiplied by 0.8. F2 times 0.8. Therefore, our F2, to get our F2, divide both sides by 0.8, 0.8. So our F2 will be equal to 225 divided by 0.8, and that will give us 281.25 Newton. 281.25 Newton. That is our F2. I hope that makes sense. So let's look at another question. Figure 4 shows a small piece of copper about 3 centimeters high. A student wants to determine the density of copper. The student uses a balance to measure the mass of the piece of copper. Explain how the student could measure the volume of the piece of copper. Now this question has to do with density, and we have to understand, we know that density is mass divided by the volume. Yeah, and we have two types of objects. We have objects that are regular objects. Now regular objects are objects that have definite shapes. Yeah, you can easily get the volume, from their shapes, right? But then we also have what they call irregular objects. Now these objects are objects that does not have a fixed shape. They don't have a regular shape, so you can't figure out, or you can't calculate the volume of such objects. Now to calculate the volume of irregular objects, what you do is this. The first thing I'm going to do is to get, let's say, a beaker of water or a measuring cylinder. Let's say we're using a beaker. Yeah, so we have a beaker. Now you add water to the beaker, and the water should be half filled. So this is the water level. So let's take note of the level of the water. Let's say the level of this water is 20 cm cube. Now you now take your irregular object that your irregular object, let's say a stone. All right, you attach a thread to the stone, okay, and then you dip it inside the beaker of water. Okay, this is our irregular object. Yeah. Now what happens is this: the level of water will rise. We know that the level of water will rise. Yeah. The change in the level of water basically is the volume of that irregular object. Yeah. So now the level of the water will then rise, let's say, to this level, from 20 cm cube now to, let's say, 30 cm cube. 30 cm cube. Yeah. So therefore the volume of that object, the volume of that object will be equal to 30 minus 20. That is the change in the volume of water, which is 30 cm cube minus 20 cm cube, and that will give us 10 cm cube. So that is basically the concept behind how to find the volume of an irregular object. So now let's apply that to this question here. So the first we're going to do is get a beaker or a measuring cylinder. So that will give you your 1 mark. Then the second thing is add water to the beaker or measuring cylinder, depending on what you want to use. Then you can just write half filled in bracket. Then what you're going to do next is to insert your insert the object And then when you add the beaker of when you add the water, okay, don't forget, take note of the level of water, right? So that should be included as well. That should be included as well. So you have take note of the level of water. Then insert the object into the beaker of water or cylinder or majorly cylinder, as the case may be, into the beaker of water. Then take note of the change, okay? Take note of the change in volume of water, okay? Change in volume of water, and then you subtract the final volume of water from the initial volume of water, and that will give you the volume of the object. So basically that is the concept, the idea behind answering this question. Hope that makes sense. So let's look at another question here. It says a different drone has a mass of 4.5 kg. This drone rises from the ground to a height of 20 meters. Calculate the change in gravitational potential energy when the drone rises through a height of 20 meters. Now, you are given that the gravitational field strength G is equal to 10 Newton per kilogram. Okay, you are asked to find the gravitational potential energy, GPE. So this question basically is under work, energy, and power. So all you need to do is to just refresh your memory on the concept behind work, energy, and power, the definition of work, the formulas, energy, and power as well. Right. So now we are asked to calculate the gravitational potential energy. Basically, this is mgh. Okay, mgh. M is the mass, G is the gravitational field strength, while H is the height. Alright, so our M is, our mass is 4.5 kg. Our G, which is the gravitational field strength, is 10 Newton per kilogram, and our H, which is the height, is 20 meters. So let's put everything into the equation. We have that 4.5 multiplied by 10, then multiplied by 20. So that will give us, now 4.5 multiplied by 10 will give us 45. 45 multiplied by 20 will give us 900 joules. Okay. Now let's look at the second one. State the amount of useful work done by the blade as the drone rises through 20 meters. State the amount of useful work done by the blade as the drone rises through 20 meters. Now basically work done is the same as the energy. Okay, work done is same as the energy. Sorry, energy. All right, so that is work done is work is equal to force times the distance. So in this case now that will be height. Yeah, that will be the work done, and force is mass times the gravitational field strength. So Basically, we're going to have 4.5 times 10, then times the height, which is 20 meter. So basically, we're going to get the same thing, 900 joules, right? So here our answer also is 900 joules. Let's look at the third one. It takes 4 seconds for the drone to rise through 20 meters. Calculate the useful power developed by the blades in this time of 4 seconds. So you have to calculate power. And what's the formula for power? Power basically is the rate of doing work, right? Which means power is work over time or energy over time. So power is equal to work divided by the time taken. And our work is 900 joules and the time is 4 seconds. So we have 900 divided by 4, and that will give us 225 watts. That is a unit of power. 225 watts. I hope that's clear. So let's look at the last question for this video. It says a student investigates resistors connected in parallel using a number of resistors. Each resistor has the same resistance, and the figure shows a circuit diagram with one resistor. So this is a circuit diagram, and the first one you have to do is to add to figure 19 a voltmeter to find the potential difference across resistor R, and second one is add another resistor in parallel with the resistor R. Okay, so now you should always be expecting questions like this under electric circuits. There will always be a question whereby you'll be asked to add some certain things to a particular diagram. It could be add a voltmeter, add resistor. Such questions are always coming out in in examination. Okay, so now all need to just understand the basic concept of your electric circuits. So now to add a voltmeter, so you have to add the voltmeter to find the potential difference across R. What is that unit? What is that symbol of potential difference? That is V. That is our voltmeter. Yeah. So we add it here. Okay. Now it says add another resistor in parallel with resistor R. So how do you add parallel? You add it below the first resistor R. So you can add a resistor here. Resistor R. So that is it. Then the second one says state the measurement that the student must take to find the overall resistance of the resistors in parallel. So now you want to find the overall resistance of the resistors in parallel, these two resistors in parallel. You want to find the overall resistance. What measurement are you going to take for you to be able to find this resistance? So basically the measurement you need to take is you need to take the potential difference across two resistors in parallel. Okay, that's going to be the first measurement. So we want to measure the potential difference across the two resistors in parallel. Then the second one will be to take measurement of the ammeter, of the current that is passing through this current that is passing through the resistors in parallel. Okay, so let's say if you've gotten your voltage, your potential difference V, and you've gotten your current, then you can calculate your what? You can calculate your R. V equals to IR. Yeah, so your R will be equal to V over I. So you need to measure the voltage across the two resistors and then the current that passes through the two resistors. I hope that's clear.